Hello, welcome back to the loop. In this segment we look at sentinel controlled repetition. One shortcoming of the gradebook application as we completed in the previous segment was that we had to hardcode the number of students in the class. In our example it was 10. Often an application like that would be more useful if it could be used to any number of students in a class. Such a program can be developed using a sentinel controlled repetition. So let's consider the following problem. Develop a class averaging application that processes grades for an arbitrary number of students each time it's run. In this example, there's no indication of how many grades the user will enter. In fact, it can vary between one run and another run of the same application. A sentinel value can be used in these cases to indicate the end of a data entry, creating a sentinel controlled repetition, also known as an indefinite repetition, because the number of repetition is not known before the loop begins. The sentinel value must be different from legitimate data, otherwise the loop will terminate on legitimate data, which is a logical error. To develop any algorithm, we can use an approach called top-down stepwise refinement. The top part indicates that we describe the purpose of the algorithm in a single sentence, such as determine the class average for the quiz. Going down, we divide the top into a series of smaller tasks, also known as the first refinement, such as initialize variables, input sum, and count the quiz grades, calculate and display the class average. So this would be our first refinement. It's important to remember that each refinement describes the exact same algorithm, and each refinement is a complete description of the algorithm, only the level of detail varies, in particular increases. At the first level, very often many applications can be divided into three phases: the initialization, the processing, and the termination phase. Going forward, our second refinement will constitute to specify individual variables. So we can say initialize variables, which can be further refined on a variable per variable basis, such as initialize total to 0, initialize counter to 0. Input sum and count the quiz grades can be refined in a second refinement, such as prompt the user to enter the first grade, input the first grade, possibly the sentinel, in which case the loop instantly terminates. In other words, we enter no actual grades, and then run the loop while the user has not yet entered the sentinel. Add this grade into the running total, add 1 to the grade counter, prompt the user to enter the next grade, and input the next grade, possibly the sentinel. Calculate and display the class average can be defined as if the counter is not equal to 0, set the average to the total divided by the counter, display the average, else display no grades were entered. We have to be careful to avoid division by 0. We have to specifically test for it because it is possible that 0 grades will be entered. So here is our pseudocode for the sentinel controlled version: initialize total to 0, initialize counter to 0, prompting the first grade, inputting the first grade, running the loop, checking for the counter being equal to 0, so that in that case we display no grades were entered, otherwise we compute the average. Stepwise refinement can be continued until the point when the pseudocode is detailed enough that it can be converted to C# code, basically line by line. With experience, programmers often can write programs without actually writing pseudocode first. However, this is practical only for simpler, shorter tasks. Really large applications have to be carefully planned and designed. So we are going to complete the gradebook application with a sentinel controlled repetition. However, before we do that, I'd like to take one more look at our original implementation, which will be a counter controlled repetition structure. The determine class average method had a loop, a while loop here that calculated the average based on 10 students. One important consideration here is that a critical instruction is incrementing the grade counter by 1, because if we don't do that in our original version of the code, suppose I comment that line out, then we create an infinite loop. So in this case, we are checking whether the grade counter is less than or equal to 10, and then we forget to increment it by 1. It was initialized to 1, and it will never change from 1, so it will be indefinitely less than 10, and therefore our loop will never terminate. Such a situation is called an infinite loop. So if we try to run the program now, it will ask for a grade, and we'll be in trouble. Suppose every grade is just 99, and then 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 99, and this will never end. And eventually I created a problem when I didn't enter any grade at all. So one more time, if whatever I enter that is a valid grade, maybe just 1, and I keep going and 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 going, and it will never end because I forgot to implement the counter. Eventually, if I enter nothing, an empty string, then I get an unhandled exception error. So the problem again was that forgetting incrementing a counter results in an infinite loop. Having said that, we are going to look at the gradebook application with a sentinel controlled repetition. It will be mostly unchanged. The only change will be the highlighted areas. So we use an average that is double in type instead of integer, so that integer division is not a problem. We are going to initialize the grade counter to 0, and then we have to enter the first grade from the user, and then we can start the loop. The loop is sentinel controlled, so it reads that while grade does not equal -1, so as long as that's the case, it continues the loop, and when the reader enters a -1, then it terminates. Then we specifically check that the grade counter is not 0, in which case we compute the average. Otherwise, we display that no grades were entered. And we don't really need to change the gradebook test class. So to carry out the changes, in our case, the initialization phase will change. So grade counter in this version will be initialized to 0. In addition to that, the inputting the grade has to happen once before the loop even starts. So we enter the user as first grade, so we prompt the user to enter a grade. However, it is not enough to say enter a grade. We have to say enter a grade or -1 to quit. And this is important, that if we use a sentinel, then we have to remind the user specifically of the sentinel value. Following this, our loop will change. So instead of a hard-coded value of 10, we are going to run the loop that while the grade value that the user entered does not equal -1, which is our sentinel value, and instead of looping 10 times, we are going to use a sentinel value to terminate the loop. Value of -1 terminates the loop. And then, since we already entered the first time, we entered the first grade even before the loop started. We don't need to do it the first time. We can right away, if we don't get a sentinel value, add the grade to the total and increment the grade counter by 1. However, after that we have to ask the prompt the user again, so that we enter the next value, and every time, and then the first time a -1 happens, we don't need to the loop will terminate, or -1 to quit. So that's prompting the user and reading the grade. So that change was necessary to be added to the code, and having done that, what's left is computing the average, but we have to prepare for the possibility of the user entering no grade at all, and therefore the total being 0. So let's comment it as that if the user entered at least 1 grade, then what we check is that the grade counter is not 0, could have written as greater than 0, same thing. So if that's the case, then we go ahead with the calculation of the average and the display of both the total and the average, thereby constituting the end of the if. And as always in these situations, we typically want to indent our lines within the body of the if. Otherwise, the grade counter is 0, the user didn't enter any grade at all, in which case we get to the else part, which is the case when no grades were entered. Oppa, I didn't quite mean that. No grades were entered. So the output, I would say output, an error message, if we call that an error message, which is a console write line. Indicating that no grades were entered, like that. So that would be our modification. There's one touch we can add, namely that when we display the class average, it could potentially have a long decimal part. So for example, if there was 3 students, say, only, and their grades added up to 100, then the average will be something like 33.333333, many threes, and we don't want the many threes there. So in that case, we want to format our string, and one way to format is to put an F, which stands for a fixed decimal format whose default is 2. So the average would be displayed as 3.33. So assuming that we reformatted our average, and one more modification, that instead of the total of 10 grades, we might want to say something that the total of first parameter here, first parameter embraces there, format parameter, and the second one is there, and the total of, and grade counter grades and total. So this is our grade counter variable, how many grades, and then the total as well as the average formatted. So this is our new determine class average method that now uses a sentinel controlled repetition construct. So we don't really need to modify anything in the gradebook, the gradebook test class at all. So we can save it all. We can test that there is no error by building it, and now we can test it by Control F5. It will come up and we'll ask for grades. Let's assume that there are only a few of them, maybe only 3. So maybe one grade is 96, another is 88, another is 79, and suppose these are all the grades we have, so we indicate that we are done entering the grades by entering the sentinel value -1. In response, we get that the total of 3 grades is 263, and the class average is 2630, which is incorrect. So we overlooked one more change that is necessary to do, namely that we are not supposed to divide by 10 anymore when we are calculating the average, but by grade counter there. So that was a modification that's also necessary. So let's try now and see if we can correctly determine the correct average. So the first grade would be 96, the second 88, the third 79, and when done, we enter a sentinel value, and in this case it looks like it's correct. So 263 is the total of 3 grades, and that's the average. Let's try a different number of grades. Suppose we try 6 grades this time, so it's 96, 88, 79, say 100, 48, and 85. We are done, so the sentinel value indicates that we are ready to quit, and we get that the total of 6 grades is 496 and the class average is 82.67. to check that the formatting worked, even though the previous one looked like one of those cases when we could have a formatting problem if we didn't pay attention. Suppose there are 3 grades and they end up to 100. So we enter 34, 33, 33. We are done. Enter a negative one to indicate the end of the input. And indeed we have that the total of all 3 grades is 100 and the average is 33.33. If we left out the formatting, this situation would end up looking not very good. So without formatting, I took out the formatting from the class average, so entering the 3 grades. And then the sentinel value results in a display like 33.3333, too many 3s. And that's what we wanted to avoid by putting a formatting like capital F, lowercase f would work as well, that allows a fixed decimal digit formatting with 2 being the default, and that's sufficient. So trying again, the same grades terminating end up as 33.33, which is a lot better. So this was the a second version of the gradebook application, and I like to display the method again, the determine class average method, where a while loop with a sentinel controlled format allows us to enter any number of grades and use a sentinel value to terminate the input. In the next segment we are going to look at nested conditional and loop statements.